So before we actually jump into finishing a quadratic table, I've given you one that's already been finished so that we can see if we can recognize any patterns or rules for finishing a table of our own. So here's the table that's already been finished. And before you go jumping in just trying to find a pattern by staring at the table, it might be beneficial for you to go ahead and plot those points on a graph so that you can kind of see the patterns forming as you're working through them. So the first point we have is at -3 and 10. Then -2 and 5. -1 and 2. And then we have a point at 0, 1. And then it starts going back up. 1, 2, 2, 5, and 3, 10. And that's what kind of forms my parabola. So what patterns do we see when we are looking at the table or over at the graph? Well, the biggest pattern that sticks out to me is that this is symmetrical. Once I went back up, I started using the same y values over and over again. I'd had y values over here of 10, 5, and 2. And then once I hit that vertex, the y values on the right side became the exact same, 2, 5, and 10. So it was symmetric on either side of the vertex. So 1 out from the vertex, they were both at 2. 2 out from the vertex, they were both at 5. 3 out from the vertex, they were both at 10. And I know that this is the vertex because it happened right in the middle. And you can see that over on the table as well. 1 out from the vertex is at 2, then 5, and then 10. Now, how much does that y value change each time you move out from the vertex? So here's our vertex, and to get from 1 to 2, it goes up 1. To get from 2 to 5, it goes up 3. And to get from 5 to 10, it goes up 5. That means that since it's symmetric and I know that the same numbers exist on the other side of the parabola, that it will also go up 1, go up 3, and then go up 5. One, 3, 5. Hopefully you're starting to see, hey, that's a pattern. Each time it went up by 2 more than the previous time. So it went up by 1, and then it went up by 2 more than that, which is 3, then 2 more than that, which is 5. So it stands to reason that our next change for the y value would be 7. And then after that would be 9. And after that would be 11. Now that is particularly true because there wasn't an a value written in there. Now, if there was an a value, then that would need to be put in as well, and I'll show you that in just a minute. But quadratic equations, as we know from graphing them and from taking a look at our tables, are symmetrical. So when we're filling in those missing values for our quadratic table, sometimes it might be helpful to go ahead and plot the points on the graph so that you can find out what the other point is on the other side of the graph. For example, if I didn't have the value at 310, I would know automatically that it would be at 10 over here because I needed to mirror that point across the axis of symmetry. And you already did that by providing 2 points on either side when you were graphing. A lot of the things that we're doing with these quadratic equations all go back to graphing, even if you are not physically graphing it for the objective. So always look when you're starting to fill in this table for any symmetric points first and fill those in as soon as you find them. Then for the other points, every time you move out 1 from the vertex, your y value is going to increase, if it doesn't have an a value, by 1, 3, 5, 7. And if it does have an a value, it'll increase by 1 times the a value. Then 3 times the a value. 5 times the a value. And finally, 7 times the a value. Now, technically, there still was an a value here. It was just 1, so it didn't change anything when I multiplied it out. Let's go ahead and see if we can take a look at a partially filled in table. Now, please note there are a couple of errors when I was typing this up. I typed into the wrong spots, so make sure that you are fixing this one and this one over here. Or if you already have a corrected copy, there's nothing to fix, but double check it. So looking at this table, I can see that I have 11 and 11. Those are matched up. So that means as I move closer, this one went to 6, which means this value is also at 6. And again, it might be helpful for you to kind of plot that over here. It doesn't have to be a specific graph. It can be just a quick, sketch, but it may be helpful for you to actually plot those points. Now, as luck would have it, I do have my sticky note graph paper, so I will go ahead and plot it here for those of you that are visual and need to see that other point. So if I were to start here, I'd plot my points that were given to me first. I have -2 and all the way up to 11, 0 and 3, 3 and 6, and finally we have 4 and 11. So I can see that these two are already mirrored, and those were 1, 2, 3, 4, 5, 6 away from each other. So if it's symmetric, that means that my axis of symmetry had to happen right down the middle. So if one of the points was at, 3, 6, then the other point would need to be at -1, 6. So if you needed the graph to see it, you can graph it. If you can do it from the table, you can do it from the table. Either one is going to get you the right answer. So one of the points is at 0, 3, and that's 1 away from the axis of symmetry. So 2, 3 would be the other side. Now the only thing that's left that I don't have just by mirroring points is this extra point down at the bottom, and I don't know what my y coordinate is for my vertex. I know that it's going to go straight through at 1, because that's where I found the axis of symmetry by splitting the difference. But here's where this kind of pattern is going to fall into play. The difference from 11 and 6 is 5. And I'm not caring necessarily about going up or down. I'm talking about the distance between them. And remember that distance is always positive. So the distance between 3 and 6 is 3. That means that if I'm following my pattern, 5, 3, the distance from here to here should be 1, which would make that at 2. Let's check and make sure our distance continues this way. So the distance between 2 and 3 is 1. 3 and 6, the distance is 3. 6 and 11, the distance is 5. So if we were to trend out, that would mean this distance needs to be a distance of 7. And we're counting up here, so we're going to count up 7 to have 18 here. Let's take a look at the next one. I'll show you one more by plotting it on paper, and then the others I will do with just the table. So I'm going to plot the points that I already have, 0 and -1, 4 and 1, 4 and -1, 5 and -6, and then 6 and -13. And that goes a little bit off of my graph, but that's all right. Okay, so here's kind of my mirrored points. So if I were to split that in half, there's my axis of symmetry. So that means this is 1, 2, 3 away. So 1, 2, 3 away. And that point is at -1 and -6. And then I have another mirrored point here that is 1, 2, 3, 4 away, 1, 2, 3, 4 away, and that's at -2, -13, but that's not part of my table, so I don't need to fill it in. It's time to find out that vertex. And we know that our vertex has got to be on this axis of symmetry. So my vertex is going to be here. So let's find the distance between each of our points that we know. The distance between -13 and 6 is 7. The distance between -6 and -1 is 5. So that would mean this next distance should be 3. So -1, and notice the trend, it's getting bigger. So -1, and I count up 3 from -1 should put me at 2. And let's see if that makes sense in my parabola. So 1, 2, 3, up 2. Yep, that looks like it would be roughly in line with where my parabola was, which means I can find another mirrored point on the other side. 1 away, 1 away. That should be at 2. 1, 2. And then this distance should be 1. So that would make this at 3. 2, 3. And that does make and complete my parabola. You can check the distance on the other side to make sure that everything is good. The distance between 2 and 3 is 1. The distance between 2 and -1 is 3. And the distance between -1 and -6 is 5. All right, in the next problem, without a table, or without a graph, I can use the table, and I found 2 locations that are the same on either side. So that means if I move kind of inward 1 each time, I'd find the mirrored points, so I don't have anything I can fill in here. But if I move in again, I can fill in at -1, -2 for a mirrored point. And that means that this guy right here is going to be my vertex. So we have -17 to -10. The distance between that is 7. So the distance between here should be 5, 3, 1. And going outward, it should be 1, 3, 5. So let's go ahead and fill in our other pieces. The trend here is that -17 to -10, it's getting bigger. So I need to move bigger from -10 to -5. -5, bigger 3 gets me to -2. That makes sense. -2, bigger 1 gets me to -1. Now we'll continue, and this time we're trending smaller because we were getting closer to the vertex and now we're getting further away from the vertex. Your other choice, if you want to continue the trend of always moving upwards, would be to start back at the end and work your way in. So -1 to 2 is 1 away. -2 to trend upward or downwards 3 would be at -5. Which again, once you filled in this guy, you should have been able to fill in him as well. Let's do another one. So I'm looking for my complete pieces here. There's a complete one. So if I move outwards 1 on both sides, I should be able to fill in this top box with 7. Move out again, and I should be able to fill in the top box with 12. And I can't move out again because I don't know what it is on the other side, so that won't help me. I did, however, locate my vertex right in the middle. So let's find the distance between each of the numbers that they gave us. So the distance between 12 and 7 is 5. The distance between 7 and 4 is 3. The distance between 4 and the vertex then should just be 1. So it's counting down. So we'll count down 1 to 3. So the distance the other direction should be 1 away, 3 away, 5 away, and our last point will be at 7 away. So the trend is going up from 3, 4, 7, 12, so then up 7 more would be at 19. Now, all of these had an A value of just 1. So we only had to deal with 1, 3, 5, and 7 every time. You'll see in the bottom that we're going to get into A values other than 1. So we may see differences that are not exactly at 1, 3, 5, and 7. So we'll need to use this pattern to fill in the rest of our table. So in looking at this table, I have a completed symmetry at 12 and 12. So if I go in 1, 9, and I can fill in the other 9, which means here's my vertex. And if I go out 1, I'm at 17. And if I go out 1 again, I'd be able to fill in this last one here, but I don't have anything on the other side to be symmetrical with. So let's find the distance between these. So the distance between 17 and 12 is 5. The distance between 12 and 9 is 3. There's 12 and 9 again. 17 and 12 again. So it's still following that same 1, 3, 5 pattern, which means my vertex should be 1 away. So it will be at 8. And then to come out here, this will be at 7 away, and it's trending larger. So it'll be at 24. Let's take a look at the last 3 here. All right, we're going to fill in what's symmetric on both sides. So I have an 11 and an 11. So moving out 1 from both sides means that this top box is going to be at 21. Moving inward, I have the top box at 5. And that top box here in the middle would be my vertex. So let's find the distance between each of these. So the distance between 21 and 11 is 10. The distance between 11 and 5 is 6. The distance between 5 and 3 is 2. The distance between 3 and 5 is 2. 5 and 11 is 6, and 11 and 21 is 10. Now that's not following my 1, 3, 5 pattern. That means that there must be an A value that I need to deal with. And how you deal with or isolate what that A value is so that you can find the next pattern is you're going to divide each of those numbers by what your 1, 3, 5 pattern should have been. That will tell you what your A value is. Each time that you divide this, you should get the same number. So starting with the vertex, moving out 1 should be 1. Out 2 should be 3. Out 3 should be 5. And each time I divide those numbers, I get the same value. That's my A value. So each time I divided those, I got that A value was 2. That means that when I go to move to my last one here, 1, 3, 5, this should have been 7, but I've got an A value that I have to multiply by, which means that it's really a distance of 14. So 21 plus our 14 gives me 35. For the next one, here's my completed symmetric part of the table. So moving inward 1 gives me 15. Moving in 1 more gives me 6. The distance between 30 and 15 is 15. The distance between 15 and 6 is 9. And this is my vertex. So the distance between here and here normally is supposed to be 1, 3, 5, 7, but it wasn't 1. That means there's an A value, and that A value was 3. So if I wanted to fill in the rest of my table, I'd have to fill in my 1, 3, 5, and 7, and I'd have to multiply it by my 3. So all the way on the outskirts here, the difference between 30 and my next value needed to be 21. The difference between here and here needed to be 15, which it is. The difference between here and here needed to be 9, which it is. The distance between my 6 and my vertex needed to be 3. So my vertex is at 1, 3. It's kind of like filling in a Sudoku puzzle. There's only one way that all the numbers are going to fit, and they have to follow the rules. One more. So here's my completed part. Moving 1 in makes this 23. Moving 1 in makes you 8. The difference between 48 and 23 is 25. The distance between 23 and 8 is 15. And then this is my vertex. So we should have followed the 1, 3, 5 pattern. So 25 divided by 5 gave me 5. 15 divided by 3 gave me 5. So that means that this is going to be a difference of 5. This distance should also be 1, 3, 5, 7. And we found our A value was 5. So this distance should be 5. This distance should be 15. This distance should be 25. And this distance should be 35. So 48 plus 35 gives me 83.